doing?
My name is Nicole Razzo, and today we're going to learn about Lewis structure. So a Lewis structure is like the one where you have an element or like a symbol or like a letter, and it has all these little tiny dots all around it. So basically what those dots mean is that it's going to show the bonding between atoms in a molecule and the lone pairs of electrons that may exist in the molecule. So basically what this means is that if you take any element from the periodic table here and you compare it to another element or even leave it by itself, it has a certain amount of valence electrons. Now, in order for an element to be happy, so to speak, it needs to have 8 valence electrons. But the problem with that is that not all of them have 8. The only ones that have 8 are the column of noble gases, but every column has different. So, for example, the first column only has 1 valence electron. Now, the exception in this column is hydrogen, because hydrogen only needs 1 to be happy. So it's one of those elements that doesn't need 8, it only needs 1. So the second column has only 2. So it kind of goes in order if you think about it. The third has 3, 4, 5, 6, 7, and so on. Now in the 8th column, where you have the noble gases, which I mentioned earlier, have 8 valence electrons, you have an exception as well. The exception is helium. So helium actually only needs 2 valence electrons to be happy. So if you were to put helium and hydrogen together and bond them together, you wouldn't need to add any valence electrons or do anything crazy to it, because they would both be happy. Now if you take another element like carbon, which only has 4, you would need 4 more. Now this concept of having 8 valence electrons and being happy is known as the octet rule. Now sometimes during Lewis structures we have either extra or less, depending. So for example, again, the helium and hydrogen relationship will only have 3 total, because a lot of elements, what happens is because they have exceptions, they are only happy with those 3. Now we also have some that include extra. So what happens in those is there's this thing called an orbital. So you have your element and then you have like these rings that go around it, and every ring holds a certain amount of electrons. So they go on to about like a big number. So you can just pack them on the outer circle until you basically run out of electrons. But very few elements do break the octet rule, but it is possible. So a way to write these, I'm going to go over some things here, is you take an element and you write down the element abbreviation. So for example, nitrogen is N, chlorine is Cl. And basically what you do is you take one of these. So for example here, we're going to use this one. And we're going to take, let's say Cl, so we're going to take chlorine. So we're going to take Cl2 and we're going to take boron. So BCl2. So basically what you're going to do is you're going to separate these. So you have 2 chlorines and 1 boron. So you're going to do boron, excuse me, and 1 Cl and a second Cl, because the subscript here is the number 2. So you have 2 of this one element. So chlorine, as we go to the periodic table, has 5, 6, 7, has 7. So we're going to go 7 plus 7. And we're going to go plus, so boron has 3. So 7, 8, 9, 10 plus 7 equals 17. So this is an odd number. So when you do get an odd number, it means that one, it could be a little bit off, or you could have some extras. So we're going to do, so then there's bonds. Okay, so let's go over bonds. So this is a single bond, this is double, and this is triple. So basically what this means is every bond has a certain power. So for a single bond, it's the same value as 2 valence electrons, and the double bond is the same as 4, and then triple bond is 3 times 2, so 6. So we're gonna do, so since we have 17, we're gonna do 2 and 4. And then we're gonna go, okay, so chlorine, how many does it have? So we're gonna go 2, 4, and then you add on 6, 7, and 8. And then you do the same for the other side. So here you only have 2, so you're gonna go 2 more, so 4, 6, 7, and 8. And boron has 1, so 1 bond, so it has 2, and we're gonna go 3, 4, 5, 6, 7, and 8. So now we count them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So we exceeded the number. So what we could do is we can now change this single bond into a double bond, and it would change the structure. So let's go down here. So we're gonna do Cl, double bond it with a Cl, and then double bond that with a B. So now we have 2, 4, 6, 8. So this one we don't need to touch, it's happy. So 2, 4, 6, and 8. And now boring, 2, 4, 6, and 8. Now we have 2, 4, 6, 8, 10, 12, 14, 16. So we're good. And that's it for today.